Hello. Hello. Happy Tuesday. I just realized. There we go. Now you guys can talk to me. Hello. Good morning. How are we doing? It's been 3 long days of no school, a long weekend. Hello. So how was your weekends? Tell me about it. What did you guys do for those 3 days? Did you guys go away? How many of you guys were up the hill? How many of you guys got stuck waiting in line on the hill because they closed some runs down? Yeah. Are you in Mexico? Did I know you were leaving? I didn't know you were leaving. How long are you gone for? I'm talking to Angelina right now, by the way. I didn't know you were going. How long are you in there for? Angelina's gone. You went riding and worked yesterday? Now, yeah, it was your birthday. So happy birthday to you. Till the 19th. Okay. Fun. Where in Mexico are you, Angelina? Who just joined us with a whole bunch of numbers? I just need to know who that is. Who is 11657? I'm not sure who that is. Cool. So did you have a good birthday anyways, Katie? T? Hope it was good despite having to work on it, but oh, nice. That sounds fun. Good. That's a little bit of time there. Yeah, I don't know how to. Puerto Vallarta, I think, is correct. Yeah. Bell. Got it. Perfect. Thank you. Just didn't know who I was talking to. Nas. Cool. So I thought it was your birthday. Wasn't it your birthday that you had to? It was Cassie's. Ah, that's what it was. Okay. Sorry, Cassie. She's not even here with us, is she? No, she's not even here. Yeah, she's not even here. She's had too much of a good birthday. So, yeah, so what else did you guys do? Some of you other people tell me, how are some things? What did you guys do? What happened? Tell me some things. I have Alyssa there. I'd love to hear what I don't think I've heard you speak very much here. What did you do this weekend? You got back from Maui, Jess? Yeah, you're back, aren't you? Yeah, you are back. Nice. Yeah. Went up to Big White. Were you there the day that it was all the massive lineups? Like I was talking to somebody and it took, in 4 hours, they got 2 runs in. It was so bad. They ended up leaving at like noon or 12:30 or something like that. It was so bad. You bought 2 fish. Oh, what kind of fish? Like little goldfish or what kind did you get? You went up to Big White as well. Perfect. And Hallie, I think you went up too as well, I think. I saw in your PE log. I think I saw you went up there as well. Goldfish. Cool. That's awesome. Good. Black Forest Mountain is... Oh, was it? Cool. That's nice. Good. What about my guys? I haven't heard anything from any guys out there. What guys? Come on. Who do I have here? I got Kaylin and I got Sean. Oh my gosh, is that the only 2 guys I have right now? I think it's the only 2 guys I have. So Kaylin and Sean, how was your weekend? What did you guys end up doing? You guys have to represent the male population right now. That's so funny. I know. It was splendid. You're not Sean. You're not Sean. You can't speak for Sean. But I'm glad you had a good weekend. Splendid. Yes, it is a very good word. That's good. Oh, I better do that too here. Sorry, 1 second. There we go. Your weekend was, you're thinking about it. Yeah. That's good. That is good. Very nice. All right. Mine was good. I went and, slides here. Good stuff. Just going to mark slate here now. On Sunday, went and saw Coco, the new cartoon that's out right now. And actually, I didn't really know what it was about. The previews that I saw for it was this dog chasing this bone that had belonged to a skeleton, like it was from Mexico with the Day of the Dead there. And so that's kind of what it was sort of about. And it was really good. It was really good. I cried a little. I cry at all things anyway. So, but yeah, I enjoyed it and watched a couple movies at home and had some friends over and made some new food dishes, which was good. And yeah, it was a nice weekend. Did a little marking as some of you guys obviously saw. Okay, thanks, Belle. Yeah, that sounds good. Just read your message. That's fantastic. Okay, before I continue, so guys, I sent a message out to all of you yesterday. PDFs, PDFs, PDFs. It's been like 5 months, PDFs. So a lot of you guys are handing stuff in Word, in like a picture clip or something. It's got to be in PDF. So you can paste it into Word and save it as a PDF or whatever. But it has to be PDF, guys. Unless there's like no reason you could, like if it's a PowerPoint, you obviously can't or something like that. But yeah. A lot of you guys, I said, hey, can't mark this. Hey, can't mark this. So yeah, PDF with everything, guys. It's the same program we're using. It's all Moodle, right? So why would it change depending on the subject, right? It's not like so study. Yeah. Okay. The other thing is when you guys are taking the picture of whatever the assignment is, can you take the picture so the page is the right way? Because if you take the picture the wrong way when it gets handed to me, it's sideways, and I literally have to like do this trying to read it. So, and sometimes I don't want to do that anymore. So I gave enough warnings and I'm telling you all right now. So if it happens like that, I'm just going to say, can you take a picture again and have it right side up and just do that, please? Because I can't flip it over in my program. So I just need you guys to make sure you're taking it so it's proper. So a lot of times you guys send me a picture, so it's like this, but it comes in like this. So yeah, maybe just double check how it looks when it comes in. You guys are able to look at it too. So just make sure everything's good. Yeah. Okay. So those were just a couple little things I need to make sure you guys knew. So we're good to go. Okay. Yeah. So this one I thought was quite funny because argon is a element, but they're all, the good ones are gone. I don't make these up. Yeah. And then this one, that was so funny, so damn funny. I really slapped my knee on that one. Yeah. Gotta make things interesting. You do. Okay, this week. So Friday is badminton. I know. Slapped my knee on that one. I know, it's really good. So badminton on Friday, and then please remember on Thursday as well, you guys have the Experience OC. I have just been told that pizza lunch is being provided, and then we sent a message to you guys about that as well. And we said if there's dietary issues or you don't like pizza, don't want pizza, whatever the circumstances, you can either bring a bag lunch or go to the cafeteria. They have a really good cafeteria there, apparently. So yeah, so that is on Thursday. So plan for that. You need to be there latest 9:30, right kind of where the buses are. I believe that's the instructions that you guys have been told. So yeah, so you guys will need to plan around that. And then tomorrow, social studies. So yeah, so today me, tomorrow Mrs. Ward, Experience OC, and that's the week. And then you got badminton. Like seriously, it's a nice week. Pizza, pizza. Yeah, we saw a commercial for pizza last night. We really were wanting it. What day is that in class lab we are doing? Monday. Monday. Yeah. So Monday 10 to 11 here. Yeah. All right. It's also all on Moodle, and it's also on the calendar, homeroom calendar for you guys. So yeah, so you can do that. I got a message from Alexis. That I don't know, Alexis. I don't know. I don't know who that's through. Who's doing the library card thing? Who told you to do that, or what is that? Is that through Mrs. Ward, or what was that through? I'm not aware of that. So if someone brought that up to you, I would ask them. Okay. I think it's tomorrow. Okay. I'll let you guys. Yeah. Yeah. Perfect. Tomorrow is a library card thing for you guys? Is that what you guys were talking about? I'm assuming. Yeah? Okay. Yeah, I think you still have class with Mrs. Ward tomorrow for sure. So as far as I know, but I'm not speaking for her because I'm not going to mess up her plans or whatever. Supposed to bring it. Can someone answer Alexis on that? I'm not sure about that. You might just have to shoot Mrs. Ward a message. I'm not sure. Okay. And what time is the library? 1 to 2? Okay. Perfect. Good. You guys are solving so many problems right now. It's fabulous. Okay. So today's plan, we are going to look at polyatomic bonds. So I started marking the work that's due today. I started marking it yesterday for some of you that handed in, and you guys are doing awesome. The ones that got handed in, you're doing really, really well. I'm making the formulas, naming them and everything, so that's really good. So you have a quiz today just on the ionic compounds, and we're going to do a little bit of a battleship prepping up for it. You got some practice worksheets, and you got a homework sheet to do. Okay, so that is the plan for today. So you guys should have your notes printed out. Ready to go. Slade is in and out on us here. So yeah, so have your notes ready to go. And if you don't have the notes printed out, it might be hard to keep up, but yeah, try your best. If not, you'll just have to watch it. And also, if you guys have been noticing, I've been putting my PowerPoints up there as well, so you can get them. Unacceptable, Sean. Unacceptable. Come on. Come on. No, it's fine. Okay. I think she says you would have. Okay, perfect. You're surviving. Good, thanks, Slade. Okay, so we are actually going to be starting off almost right away. The first slide is going to be the first little bit of the notes. So get ready to go. Here we go. Polyatomic. Yeah. Okay, poly. Poly is a prefix which means many. So, for example, polygamy means many wives. We have polygon, which means many sides, and then we have polyatomic, which means many atoms. So that's going to be that first line. So we're starting off right away, first line for that one. So poly means many, and so usually when you see whatever the word is afterwards, it usually means many of whatever that is. Okay? So polyatomic ions, so we're looking at having many atoms is what we're going to be looking at. So some some ions, called polyatomic ions, are made up of several atoms joined together, ironically joined with covalent bonds. So you guys learned about covalent bonds last day with Mrs. Wyatt. So what we're going to look at is when we have several ions that are, or atoms that are actually joined together. Okay. And so here is a picture of one that is showing a whole bunch of ions, atoms being put together and being a polyatomic ion. So the whole group has a positive or a negative charge, not individual atoms. So when you have a polyatomic ion, it's the whole thing is considered just like itself, its identity as a whole thing, not the little bits that made it. And so the big chunk of it is what is given that charge now, okay? Oh, no, yeah, so, okay, you guys wouldn't really know this yet, my grade 8s would. So, okay, so Blackboard is its separate thing. So what we do here is not through Blackboard, it's through YouTube, so it's a totally separate thing. When we record on Blackboard, so when I do that with my grade 8s or when I was away and Mrs. Wyatt did it with you guys, it gets recorded on Blackboard. Blackboard is having extreme issues right now. It took last week, I think Monday, we finally got 2 weeks of recordings. All of us had no recordings for 2 weeks. So people who were absent had like nothing to look at. So we finally got those, and now it seems like it's not working again. So there is no recording right now. I went and double checked and everything. So I am going to probably email or phone again, because that's what I had to do last time to see what's going on. They fixed it and all of a sudden our recording started showing up. So I'm hoping that'll happen. So there is no recording. I know, I'm so sorry. So just look at the PowerPoint that I posted on there, and it should help you go through the stuff, I'm hoping, okay? All right, good. Oh, you don't think she recorded? Okay. Either way, you got the PowerPoint there that you guys can look at, so. Okay, so polyatomics can be identified easily because the compound will have 2 or more capital letters in it. Okay, so we have Na, which is sodium, and the CO3, that's a polyatomic ion because it has that whole thing put together has more than 1 capital letter in it. So you know that it's going to be 2 or more than that. Okay, more than 2, sorry, so 3 or more. Technically is probably the better wording for it. All right. All right, so that is that first little chunk, and then what we're going to do is I'm just going to give you guys some examples here of some polyatomic ions. So if you look the formulas, if you look at them, they have two NO3, OH, HCO. So they all, those are its own identity. That's what it is. It's not like we're going to separate that out or change it or anything like that. That's literally the name of that ion. So these are the ones that are called polyatomic, and they stay like that. It's not going to change. If it changes, it's no longer going to be named whatever it is. So if I take the 3 away from the oxygen there for nitrate, it's not going to be called nitrate anymore, right? It's going to be NO, which is going to have a totally different name, maybe a different charge, that sort of thing. So these are polyatomic, and they're almost like they're glued together, the covalent bond kind of thing. And if you notice, all of them end in ATE. So when we were doing previous ones with non-metals, we started ending them in IDE. These ones, polyatomics, are easy to recognize because they end in ATE. All right. So on your sheet of paper, I asked you to give a couple examples. So just take some of those and write them down. And what I've also done, this was from the first lesson we did with this, with chemistry. I gave you guys one of these sheets. It was the sheet that had the periodic table on it, had the little cheats of their charges and everything. And then on the back of it, it had all the prefixes that you guys learned last day, so the tetra and the di and all that kind of stuff. And then it also had the polyatomic ions on there, so it's kind of a cheat sheet. So hopefully you guys have printed that off, because that's going to help you with this stuff today. So you already have this kind of all set up for yourself. All right, good. Okay. And then we have a couple on the bottom here. That made me look like I was scrolling down. That was awesome. Yes, it's not, most of them do. It says usually. So if you guys look, it says the ending is usually ATE. It's not a legit thing all the time. So, yeah. All right. Yes, not all the time. Okay. And so this is, like I was telling you, this is the sheet of paper. So this is on the back of the sheet of paper that I gave to you guys on the first lesson of chemistry. So there's a whole bunch more here. And like I said, the prefixes are there. So there's some other acids there. So common acids are written there for the sulfuric acid. I want to do an experiment with sulfuric acid, but I'm actually, because I don't have a full-on lab here, and it's a quick demo, it's not like one I want to have us go to KSS and do, because it's such a quick thing. But I really wanted to do something with you guys to show it. It's really awesome, but yeah, sulfuric acid is not a good acid to be working with, and so I thought it'd be kind of nice to have like a proper lab to do it, and it's not going to happen. But so it's okay. I found some other stuff to do with you guys, so that's all good. Oh, Emily, are you with us now? Yay, I missed that one. Hey, what did she say to me? Let's see. Yes, you can, Emily. Yeah, okay. Perfect. Are we still missing Cass? We're still missing Cass. We're still missing Dean and Madison, I believe. Okay, perfect. Just double checking because I missed Emily coming. Okay, good stuff. So polyatomic ions. So we're now doing the writing of the formula. So what is the formula for sodium sulfate? Oh, wow, KDP. I'm going to no, it's because my laptop audio broke. We don't have a printer, and I have no idea what's going on. So I'm going to listen and learn. Do you want to know? But do you know what time the lecture might be posted? Oh, as soon as I'm done teaching, I'll go and post it. Yeah, so as soon as it's done, it'll be up. Okay. So what is the formula for sodium sulfate? So the steps remain the same as when we were creating the ionic compounds. So what we've been learning how to do that with an ionic compound is going to be basically the same. But this time we see the polyatomic ion as one thing, okay? Instead of like when you see the N and the C and the O or whatever it is, that's one group, one thing. Okay, perfect, good. All right, so this is just an example. So sulfate, sulfite, those are polyatomic ions. They stay together. So notice that the SO4, the whole entire thing has a -2 charge, and same with SO3. And like I was saying, as soon as you change one thing on there, You're changing whatever it is. You're changing the components of it. Having one less oxygen atom is definitely going to change a lot of the characteristics of that ion, right? So you have to be careful when it is a polyatomic ion, you keep it an ion and don't change anything, or else it's totally not going to be what it is. Nope, not yet. No. Okay. So step one. Oh, yeah, that one part is. This part right here. Right there. Where it says 1. Oh, I didn't mean to click it. Oops. That's that first line. So it says for, on your notes in the middle, it says in black, polyatomic ions, writing formulas, and it says same as writing. It's pretty much what it says there. And then it says seen as how many elements, and it's 1 element. Okay? All right, so now we're on step 1. And the example on your sheet is sodium sulfate. So it says find the symbols of the elements and their charges. So polyatomics are on the polyatomic list, on the not on the periodic table. So you're going to have that list next to you. That's why I wanted you guys to have that printed off. Okay. So identify each ion and its charge. Okay. And then here's the example on your sheet below number 1. So we have sodium, because we're doing sodium sulfate, right? And so sodium has a positive charge of 1, and we have sulfate, which has a negative 2 charge. So same procedure as what we were doing when we were doing the ions. All right, so step number 2. So I just rewrote that again for you guys because we're continuing on from step 1 going to step 2. So step 2, you need to balance the charges by doing the crisscross applesauce method, okay? So any charge crossed down to the bottom must be put into brackets around the entire ion, okay? So what I'm saying here is that SO4, that is the ion. So if you are putting a 2, a 3, a 4 for that ion, you have to put brackets around all of those 3 parts of it, because all of that has a 3 charge or whatever, something like that. So this is just an example of, and on your sheet it shows that. So this is showing the crisscross applesauce. So I'm going to take the 2 from the sulfate, go down to sodium, and the sodium 1 goes down to below the sulfate. Okay. Number 3, the result. So now this is what I was talking about. So this is where you have the sulfate. It's one identity, it's one thing, it's what it's considered. So the 1 coming from the sodium has to go with the brackets around sulfate, okay? So, and again, we don't show the 1, right? But that is just an example of how that's going to look if it was a different number, okay? So if we were to write sodium sulfate, the bottom one at the bottom right there where it says Na2 and SO4, that's how you would probably write that. Step 2 is balance and crisscross, yes. Good, perfect. Okay. And step number 3, it says if there is more than one polyatomic ion, you must put what around the whole ion? What do you have to put around the whole ion? Brackets, perfect. Thanks, Luna. Yeah, so you got to put brackets around it. So that's number 3. And then the last one, number 4, says, remember, only reduce the charges outside of the polyatomic ion, okay? So if it's inside the brackets or if it's a part of the whole polyatomic ion, you don't reduce that. So I will never reduce that 4 and that 2 because the SO4 is one chunk, it belongs together, so that never changes. If I had a bracket around it with a 2, then I could do some reducing, but right now I can't do reducing, okay? Because technically there's a 1 around it, and 2 and 1, there's nothing more I can reduce with that, okay? So that's number 4, do not reduce. All right, so we're gonna go over a couple examples, and that's at the bottom of the page for your notes. So what I've done on the left-hand side, just kind of giving you some cheat sheet. I think it has everything that you need on there, I hope it does. So what I want you to do is, actually we're going to do this one, we're going to do these together. So we have ammonium sulfite, And so what we have to do is figure out what the ions are, ions, atoms, and we have to figure out their charges. So we have ammonium, which is NH4. So if you look over on the right-hand side, that's a polyatomic ion. So that is its name. It's one identity, NH4. And it has a charge of +1. So that I just got off the table for looking at polyatomic ions. So that's where that came from. So nothing is, basically I'm just copying off of here. That's all I did there. And sulfite is down at the bottom here, and it's another polyatomic ion. So it is SO3, and it has a -2 charge. Okay, so not doing anything special here, just looking at the table, looking at the chart, and copying that information down. Okay, and then it's the same thing as what we were doing with the ionic compounds, and it's just doing the crisscross applesauce. All right, so I'm going to take the 2 and put it with the ammonium, and I'm going to take the 1 and I'm going to put it with the sulfite. We're at the bottom of the first page. We're doing the example. It says example. So you guys are writing all this down. Reduce. Yes, the last blank is reduce. All right, so if we do crisscross applesauce, I'm going to get the 1 goes over with the sulfite, and I'm going to get the 2, and that goes over with the ammonium. And so when I do that, this is a really good example of showing what happens. So the whole entire ammonium polyatomic ion formula has brackets put around it with the number 2, because that's the charged crisscross applesauce from sulfite. And then this one has a 1. We don't have to put brackets around it and do the 1. Okay, so that's the first example at the bottom of your page there. And we're just going to do the second one here. Okay, so any questions on what happened there? So you guys should be in good practice with this, because you guys have been doing the crisscross applesauce for quite a bit now. Voila! There we did a water. Okay, good. Good. Okay. So the other one we're going to look at is lead to perchlorate. And when we look at this, is also at the bottom of your page too. So lead is Pb, and because it's a 2, it means it's the 2 charge. So this is one of those multivalent ones, right? So those are the ones that have multiple charges. So because it says it's a 2, then we know that it's going to have a +2 charge. All right? So you guys should be writing this stuff down at the bottom of that page there. And then this guy is up on our chart here. This one is fun because it's got 3 capital letters. Ooh, so special. And it's got a charge of -1. Okay? And then when we do the crisscross applesauce, we write those down. We got the 2 charge going over there. We got the 1 charge going over there. Dean has joined us. Fantastic. And when we do that, we have to put brackets around the CiO4 and put that there. Okay. All right. So that is how you write polyatomic ions, how you take the words, the name, and you create the formula. So that's that. You guys, it's nothing new. You guys already knew how to do that, which is so fantastic. Okay. So now what we're going to do is look at naming them now. So what we're going to see is what happens when you're given the formula and how you decide what the name is. Okay. All right. So what is the name of the compound KCIO? All right. So we're on the top of the second page now, for all you note people. So, for example, KCIO. So step number 1, you name the metal or the positive ion. So for example, in this case, the positive ion or the metal is K, which is called potassium. Okay? We're working on it. We're working on it, Katie. You're so excited. Dean sent me a message. Oh, gotcha. Okay. Thanks, Dean. I'm not telling you. I'm not telling you. You gotta wait. Okay. So you find the so step number 2, is find the polyatomic or the negative ion on the polyatomic list and write its name. Okay, so in this case, it is CiO, which is hypochlorite. Okay, so that's step number 2. And then do not change the endings of any of these. So we don't change the endings. So before we were changing to IDE and stuff like that, you're not doing that with these ones. When it's a polyatomic ion, it stays with whatever name it is. You're yelling at me, Katie, I get it. It's all good. All right, so that's basically number 3 where it says do not change the name endings if it's a polyatomic ion. All right, so that is this name, potassium hypochlorite, okay? So what's really cool is you guys have that sheet that tells you the polyatomic ion names. You don't have to change anything. What it says is what it is. You're good to go. You just have to figure out what the metal is or the positive ion on the front of it. It could be 2 polyatomic ions. So yeah, so it might be easy that way. So that's naming. It's really, really simple with the naming. Okay. Let's see here. So this one, oh, sorry, there's a hint at the bottom. Hint, when you're dealing with polyatomics, you will have at least 3 capital letters probably within it because it's going to be, there's going to be probably 2 in this one and maybe 1 in this one. So that's how you can tell that it's going to be a polyatomic. So that's just a little hint. Okay, so we're going to try this one. It says examples on your sheet. There's 2 examples. And I believe I've given you the information you need for the polyatomic ion names. Number 2 says do not change the ending. And CiO is hypochlorite. Okay? And you can always go back and check it too. Okay. So what I want you to do is we're going to look at this. So what is Al on your periodic table? So it's going to be one of the metals. So what is Al on yours? Aluminum. Good. And then looking, oh, I don't have it on the right-hand side. Oh, Miss Mac, she didn't do it. Does anyone know or have their sheet handy? OH, what would that be? Can anyone find that? What is the polyatomic ion OH? You guys are looking good. Hydroxide, excellent. So when we do this one, it's just a combination of aluminum hydroxide. That's it. And the 3 is there. Yes, the 3 is there, but that has to do with the charges and the crisscross. So that goes back to what we were just doing, taking the name and saying what its charges are by crisscross applesauce. So that's how that formula got written out. But the name is basically aluminum hydroxide. Okay, what is NH4? Is that on your sheet? It is. What is NH4? What is NH4? Subscript 4. What is that one? It's on the screen. It's on the screen, guys. What is NH4? Come on, people. Come on. There we go. It's ammonium. Good. And what is PO4? What is PO4? Don't tell me the whole name, but what is PO4? PU. What is PO4? It's on the screen. On the screen. There we go. Phosphate. So basically when you put these together, you get ammonium phosphate. So naming them is quite easy, especially with polyatomics, because despite having a ton of letters, it's still got like one little small name there. Okay? All right. What I want you guys to do is I'm going to give you guys 4 minutes, and you have 4 questions there where it says try these on your paper. I want you to try those 4 questions. Okay? Nope. Showing your answers. Okay, so the first one is potassium nitrate. Second one has an actual chemical formula. Third one says calcium bicarbonate. And the 4th one is chemical formula. So I'm going to give you guys 4 minutes, and I want you guys to either write its chemical formula or write its name. Okay? So you're probably going to have, like I said, every single time, always have that periodic table in front of you. You're probably going to need that, and now you're going to have that polyatomic, but if you print it, it should be on the other side or 2 papers. Okay? So 4 minutes. See you in a while. Okay, if you didn't have enough time, that's all right. We're just going to keep going. So potassium nitrate. So we have potassium is the K with a positive 1 charge. And we have nitrate, which is NO3. It's a polyatomic, and it's a negative 1. So what's really cool is because these are charges, so that means there doesn't need to worry about the crisscrossing. They're ones. It doesn't matter. So when you do that, you end up getting the final answer of KNO3. How many of you guys got that? How many of you guys got? Oh, you can't see my hand. There it is. Oh, hey. Yeah, good. Fantastic. Good. All right. So the next one. So this one, you're given the formula. Now you got to find the name. So we have Na with a 2, and because it's not polyatomic, we know that 2 has to do with that crisscross applesauce with the charge. Okay, so we know that it is going to be sodium. And so because SO4 doesn't have a bracket around it, it means it's a 1. So that's why sodium has a +1 charge. And then that 2 from the sodium uncrisscrosses and goes up with the SO4, okay? So now we can see that we have what the actual names are. So now we just have to look them up. We got sodium as the Na, and we have sulfate, and that's it. So it's nice and easy when you don't have to worry about making the charges. You have to name them. You just have to try to figure out what they are. Yeah, good job, KT. Woo! High five online. All right. And then you had a couple more here. So we have calcium bicarbonate. So this one, you have to worry about the crisscross applesauce stuff. So we have, just giving you a whole big answer right there. So calcium, is +2. And then we have bicarbonate, which has 3. It's one of those big ones. HCO3, and it's got a -1 charge. So then you do the crisscross applesauce. The 1 goes down with the Ca, which we don't ever keep, right? That's just showing you the crisscrossing. And the 2 goes with the bicarbonate with the brackets around it. And your final answer, you don't put the 1 there, sorry. My answer on my sheet of paper has no 1, so don't have the 1 on there. So don't have this 1, that was just showing. There should be one more thing here, sorry. My bad. Yeah. Yeah, that's good, Katie. Yeah, that's perfect. Okay, and then this one, so we have potassium, sorry. So we have lead, and it's a Pb, okay, and it's a +1, and then we have the sulfate, which is the SO4, which is -1. So here we have the 1 and the 1. So it says we must have been, so if you look at the actual formula, it says since lead is +2. So this is where, if you remember when we were doing the ionic ones, and you uncrisscrossed, right? And we have a 1 and a 1. So just like we have Pb as a 1, and we have SO4 as a 1. So we've uncrisscrossed, and we got 1 and 1. The problem is you always have to go back and look and go, is that actually correct with the charges? Yes, we've uncrisscrossed correctly, but is that correct? And it's not, because Pb, do you mind just taking me off there if my arms are going on the screen? The Pb is actually a +2. So if it's a +2 and it's actually showing in the uncrisscross as a 1, that means we've had to do some reducing there, okay? And Pb can be a 2 or a 4, but if you go and look at what sulfate is, sulfate's a -2. And because it's a -2, that and then we know that we did some reducing to get a 1 and a 1, they have to match. So that means that the lead that we were looking at was actually the 2 charge, not the 4 charge. And so because lead is a 2 positive, and we know that the sulfate is a 2 negative, reduce, get 1 and 1, and then that does the crisscross applesauce of the 1s, okay? So always do that, even with the ionic compounds. It doesn't matter if it's a polyatomic ion or whatever it is. Always, when you uncrisscross applesauce, go, was there any reducing happening? So always be careful of that. And this is an example that there was reducing. It could have been Pb4 or Pb2. And because we have to look at what the charge of sulfate is, that helps us decide which one it was, okay? And so because of that, remember, this is multivariant, so you have to put the Roman numeral brackets. So we have lead 2 sulfate, because we determined that it was the 2 in order for all the reducing to work out properly. How many of you guys, well, some of you guys might not have got to it, but how many of you guys actually kind of saw that or now can see that? How are we doing with that one? That one's a little bit of a fun one, just because you have to actually go back and really understand what the charges are, okay? I got one response. How are we doing here, guys? Couple. All right. So I'm hoping that some of you guys will be getting it. It's just a matter of just looking back and looking at the charges. So uncrisscrossing applesauce is not the last step, right? You have to always know what the actual charge is, and that's why you have the periodic table. You're going to sleep with it. Put it underneath your pillow, you know, like sleep with it. It'll like totally osmosis into your brain and all that kind of stuff. Yeah, tattoo it on the back. Don't tattoo on the back of your hand, but like put it back of your hand, you know, that kind of stuff. All right, good. Okay, so we're now going to the next part, and it says, making things more complicated. We got the math scientists. Wow. Okay, so things more complicated. When you have a different amount of oxygen atoms, that's the answer to that one line. When you have a different number of oxygen atoms, it actually changes the name and the composition and the type of atom and the ion and the characteristics of it, changes all that stuff, right? So if there is reducing, we use the number it was reduced to, not from. This is when we're trying to name it, Jess. So when you're uncrisscrossing applesauce, that is going to be its final reduced one, right? Because when you guys are actually naming the formula, you reduce it and that's your final answer. So your final answer is always the reduced one. So when you uncrisscross, that's the reduced uncrisscross. Now you have to figure out what it was before it was unreduced. That's how you figure out the name of them. I hope I answered that. Okay. So yeah, so with 3 oxygens, it's nitrate. With 2 oxygens, it's nitrite. All right. So, and on your notes, there's nothing to write down. It's just me showing this. So for example, sodium nitrite would be a sodium 1, and a nitrate is a 1, and so it would be this one. I just realized I have some writing mistakes there. That should be an A. That should be this one. That should be an I, guys. That should be nitrite. That should be an I, okay? Number of 1 atoms. I don't know what you're asking me, Jocelyn. Sorry. What are you asking me? Number of what atoms? Oh, oxygen. That was, yeah. You gotta listen, Jocelyn. I said the answer. Yeah. So this one, that should be an I, and there should be nitrite. So if we have sodium nitrite, sodium is 1, nitrite is 1, so it just stays like that is. You know, Jocelyn, you make sure you tell that Wi-Fi to start working and say, you're making me mess up, Wi-Fi. What you doing? Okay, so here's what's going to happen. I am going to give you guys, oops, what's going on there? Oh, yeah, sorry. And then the next one here is just looking at, again, this is looking at changing the oxygen atoms. So for example, sulfate has 4 oxygens, 3 oxygen sulfite. So this one, sodium sulfite, we have that as an example, and then it comes together like that. So the oxygen atoms change the name and the characteristics and everything of the polyatomic ion. You don't need to really know much about that because I'm not making you memorize the formulas or anything, but it's all on that sheet of paper with all the polyatomic ions there for you. So if an ion charge of more than 1 is a nitrate, don't go by that. No, just know that the amount of oxygens is what's changing the name and the characteristics in these examples, right? So in this one here, when we're looking at nitrogen and adding oxygen, when you change the number of oxygen, it changes the name and the characteristics. And then this one here is just showing when it does the exact same thing, it changes it. So don't think because it's SO, the number doesn't matter. The number does matter. The subscript does matter. So that was just me pointing out that it does have an effect. It does change its name, which means it changes exactly what it does. It changes how it relates with the other ion in the group, the other atom in the group, that kind of thing. Okay? All right. Now, here we go. Okay. I'm going to give you guys, what time are we at here? I'm going to give you, I'm going to give you guys 15 minutes. And what I want you to do in this 15 minutes is I would like you to answer them. So if it's in a formula form, I want you to put it into words. If it's in words, I want you to put it into formula, okay? And there are 13 questions. And so all you have to do, the easier ones are obviously the ones that are in formula form. The word ones, you have to find the charges and do the crisscrossing. With the formulas, you have to uncrisscross. So just a little bit of practice of what we're doing there. And then we're going to come back and mark them. And then we're almost done, all right? So I will see you guys in 15 minutes. And that's all good, Emily. Okay, so in 15 minutes, I want you guys to work on these questions, okay? See you a while. We're back. Hello. Hello, everybody. Sorry, I'm picking. Ha! Hello. Okay, we're back. All right, so let's see how you guys did. I am just going to start off with the first 6 on the right-hand side, and then on the left-hand side, we're going to start with those first 6, and then on the right-hand side, I'm going to give you guys the answers, okay? So we're going to start with this one. What did someone get for that one? Oh, Luna sent me a message. Okay. Calcium sulfate it is. Yes, good job. Ding-a-ling. All right, number 2. What did you guys get for this one? What did you guys get for number 2? Magnesium chlorate. Anyone agree? That's what Katie T thinks. Oh, we have a little bit of a difference. Just chlorate. Yeah. Perfect. Good. Next one, Li2SO4. There is a polyatomic ion at the end of it. So what did you guys get for that one? Lithium sulfate. Anyone else agree? Disagree? Disagreeing is good. Making mistakes is good. We learn. We get lithium sulfate. Excellent. Good. NaNO3, we have a polyatomic at the end. Argon, we have a metal at the front. We have sodium sulfite. We have sodium nitrate. A couple different answers. Sodium nitrate. Yeah, because it's an N, not an S, so it'll be nitrate. Now, doing the formula. This is going to be tough to type, so I'm just going to show it. So for this one, we have sodium, which is Na, so, phosphate is PO4, and then we crisscross, and because it's a 1 for sodium, we don't put anything on after phosphate, but 3. It's a 3 for phosphate, so when we crisscross, it goes to 3 on the bottom. And then potassium nitrate, we have the K for potassium, nitrate is NO3, and they crisscross applesauce, and we are good to go with that one. Okay? Give me a check mark, meaning I get it, I got it, I'm good with it. Give me an X if you're, I don't know what I'm doing, I'm totally lost. Okay, so give me some check marks, some X's, let me know what's happening. All right, Emily, love to see you for some help. Kaylin and Angelina, love to see you guys for some help. If you have some questions, you can do that. If you have a question now, ask me. So is there something that happened right now that you were unsure of? So are you guys able to see, where's my mouse? There's my mouse. Are you able to see the polyatomic ion name? The word ones I didn't get, but the other ones I did. That's funny because the word ones I would think, oh, I'm stuck in my microphone. The word ones I would think are a little bit on the easier side. 5 and 6. So what you have to make sure you do, so go back and look at the notes again. But what you need to do is go, okay, what is sodium? Sodium is Na. Okay, look at the charge for sodium. You have to look at the periodic table. Okay, then which it's a 1. Okay, and then you look at phosphate, and phosphate is on the page that shows all the polyatomic ions. It's PO4. So you have Na on one side, you have PO4 on the other side. And then you have the charge for phosphate. It's going to tell you it's going to be a 3-. And then all you take of the charges, the 1 and the 3, and you crisscross them down. That's it. So it's the same thing as what we were doing with ions. Nothing has changed with the ionic stuff we did a little while ago. Okay. Oh yeah, practice is, yeah, you definitely practice is always a good thing. That's why I always give you guys those practice worksheets with the answer keys, because then you can just practice. You don't have to worry about handing anything in. You get to do whatever question you want to do. You can see the answer and you can go from there. Yeah, you can, but what I would suggest doing is maybe just go through some of the practice ones and re-watch the slides and stuff like that. And then after you go do some practice ones, if you're still really confused, definitely, absolutely, yeah, yeah. Sometimes, you guys have to remember there's like 3 phases to learning in a way. One is the learning of getting the actual information. So what you're doing here is you're watching me show you how to do this, and you're kind of like, okay, now you got to go do it yourself. Now you got to practice it yourself. Now you got to do a few of them. You got to work on it. You got to make mistakes. You got to go, oh yeah, and all that kind of stuff. And then you get to the stage where you're like, I can do most of it pretty decently. So you guys right now at the beginning stage, a lot of this is going to be, you're really fumbling, right? When you guys go and do some of the practice worksheets that I'm showing you guys and all that stuff, you'll get into that middle stage where you'll start getting it, right? So that's where I want you guys to be. If you're still stuck in the middle stage and you're really not getting it, that's when you can kind of go, okay, Miss Mac, it's still not working for me, okay? All right, and then the last one, so we're on the right-hand side column. So this one is iron 3, which means because it's a multivalent one, we have to make sure that the 3 is telling us the charge because it has more than one charge. So this one, because it's a 3, the 3 crisscrosses and goes over, and nitrite is a 1. So that's why there's nothing below the Fe, which is iron, because it's a 1. Okay? It says it's a 3. Are you talking about iron? It's a 2 or a 3, but in here it's saying it's a 3, so there's no question about what it is. It tells us it's a 3 on there. Is that what you mean, Angelina, or are you meaning something else? Okay, cool, good. Okay, so magnesium phosphate. So we have to find out what the magnesium, we have to find out its actual formula name, we have to find out its charge, we find out phosphate, we find out its charge, and then we crisscross. And when we do that, we find out magnesium has a charge of 2, and that 2 crisscrosses over to phosphate. And then we have phosphate, which is a charge of 3, and that crisscrosses over down to magnesium. Okay? All right, aluminum. So aluminum has a 2 below it, but that 2 represents what it was from carbonate. Okay, so that 2 crisscrossed from carbonate and went down to the aluminum. And the 3 with carbonate actually was a 3 charge of aluminum, so we crisscrossed that way. Where does the 4 come from? That's part of, so guys, you have to always look at the polyatomic ion sheet. The polyatomic ion sheet is a sheet that tells you those are polyatomic ions are that group. It is its own identity. So PO4 is the name of phosphate. Carbonate is CO3. That is its name. So those are the ones that we've been working on this whole entire time. That's that entire list. So that's all of these guys. That's these guys on the right. This is just a little small example of it. But remember I told you there is that sheet, this sheet. So remember I told you guys that you should have this printed off. These are all the polyatomic ions that I'm giving you guys. Okay? So you have to always look at that. So when you look for phosphate, usually the clue is ATE. It's not always, or ITE could be another example. But you always have to be looking at that. We're working on polyatomic ions, so because we're working on polyatomic ions, most of them are going to be on the polyatomic ion part. Okay? Okay, does that make sense? Well, good. Okay. Okay. So iron 2. Yes, iron has multiple charges. So number 1, it had a charge of 3. Iron in this case is a charge of 2. So that means it's going to have a positive 2 charge, and phosphate is same as number 2, it's PO4, and is a charge of 3. So they crisscross applesauce, the 3 goes below the iron, and the 2 goes below the phosphate. And we put it in brackets so that the whole entire thing, because it's a polyatomic ion. Okay, this one, we have Cu and NO2, and so when you uncrisscross applesauced it, you find out that they both have, that nitrate has a charge of 1, which means that copper had to have a charge of 1 as well for them to reduce and stay as 1. So that's copper 1, that's Roman numeral, it's multivalent 1. Okay, and this one, Ag, is silver, and ClO is chlorate with the 3, sorry. So when you uncrisscross applesauce, neither one of those is a multivalent, so you don't have to worry about having any brackets or any Roman numerals. How you know it's multivalent is when you look at the periodic table, it'll have more than one charge on there. So it'll have a +2, a +3, a +4. That means it's multivalent. These cases, now that neither one of them are multivalent, and it's just silver chlorate. so you don't have to worry about the charges with that. And then this one, manganese has multiple charges. Sorry, can you just move me out of the way there, Magic Merle? Thank you. So manganese does have some charges. So if you look at this one, so if I'm going to look at this charge, this 2 means the 2 is connected with the crisscross applesauce. It was with manganese, okay? And it looks like there was a 1 here. But here's the thing, manganese has, when you look at what carbonate is, carbonate actually has a charge of not 1, right? And so when you go and look at what carbonate is, and in order to make it a 4, so this would become manganese, it says it's a 4, but it became a 2. So that means we reduced it by 2, and which means that if we reduce whatever charge went with carbonate, if we reduce that by 2, it got us a 1. So that means carbonate, when you look up the charge for carbonate, it's going to say it's a 2 negative. And because this is a 2 negative, but oh my gosh, look, it became a 1. That means we did some reducing. That goes back to that lead example we did. So because we did some reducing there, we reduced a 2 to a 1, which means we divided by 2, which means whatever the charge for manganese was, we reduced it by dividing it by 2. So what number divided by 2 gets you 2? It's a 4. So that's why it's manganese 4. So this is another example of just like the PB one, the lead one, where when you crisscross applesauce and you go and look at their charges, one of the charges is wrong. And what that means is there was reducing. So you have to look at what originally was, and whatever originally was, how did it go from the original 4, right? Or actually, let's look at this one. Carbonate was a 2. So if carbonate was a 2, how did it go from a 2 and make it into a 1? Well, it had to have gotten reduced by 2. So then if that got reduced, you have to do that to the other one. And so what number, if we reduce by 2, gets us to this 2 here? Well, it's 4, and that's why it's manganese 4, not manganese 2. So always, so that's just another example. I'm always going to throw in one of those like that, where the reducing changes the formula, and when you're trying to find the name, it does affect that. You will have practice on that, so that's totally fine, okay? So that is that. So if you have any questions that are easily answered right now, that's cool. If you're kind of a bigger confused, do some practices. So I have the answer keys. Go and do some of the practice ones, see how you're doing, and then if you're still confused, do that. So does anybody have a quick question here about how any of these got done? So is anyone confused about like maybe how the name got turned into the formula or vice versa? Does anyone have anything they want to ask or they're not sure of? I believe I can write on this. So, yeah, I can. This is actually a charge of 2. This can be +2 or +4. So I'm just going to show this one a little bit more here. So because, actually I'm going to draw the arrow, sorry. So when we uncrisscrossed applesauce, technically this should be a 2 and this should be a 1. But that's not right, because when you look at this, the actual charge for carbonate is a -2. So we can see that something happened, because on the actual answer, it's just showing a 1 here. When there's no number showing it's a 1. So it went from a 2 to a 1. So that's where I know there was some reducing involved. So it got reduced by 2 in order to turn into that 1, which means over here, this guy got reduced by 2 to turn into this 2, or this 2, however you want to look at it. It's the same thing. So which one of these numbers reduces by 2 to get to 2? Well, it's obviously going to be the 4. Okay? So that's how you just kind of, you work at that. So you do the uncrisscross applesauce. So this is the uncrisscrossing applesauce. So you do that, and then you go, okay, what are the actual charges? And you're like, whoa, 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 whoa. You're like, no, carbonate is not, it is not a -1 charge. It's actually a -2 charge. And when you start doing that, then you know that there's some reducing going on. That's all good. Okay. So really suggest get some of that practicing going. And then, you know, shoot me a question, go, okay, Miss Mac, I did this question, here's the answer, have no clue how that happened. What did I do wrong? This is what I did, you know, that kind of stuff. We can totally work on those sorts of things with you guys, okay? All right, so I'm gonna slowly end class here. I got a couple things to show you, and you have 2 things you have to do today. There are 2 things you have to do today, okay? So this is the first thing I wanna show you. This is, I wanted to find a way of making this a little bit easier to understand. Okay, so when is a metal and or non-metal and a non-metal? When is it a covalent bond? When is it just a typical ionic one? So I found this one, which is a little bit basic. So it says, okay, is it a metal and non-metal? If it is, then it's going to be ionic, which is what we've learned, or polyatomic, which is what we just did today. Okay, so it's going to be one of those 2. If it isn't, that means it's going to be a non-metal and a non-metal, which means it's going to be a covalent one or a molecular one, which is what we've been working on a couple classes, okay? And the covalent ones are, you guys did a little bit of homework on that last day as well, okay? So this is just an example. And then what I've done for you guys is in today's lesson on Moodle, I've given you guys this flow chart. It might help some of you, it might not. If you find it confusing, don't use it. It's up to you. I'm just trying to help some of you guys that need to visually see some things. And it sort of goes, okay, if it's this and this, and it tells you if it's yes, you go this way, if it's no, you go this way, and then you follow it along, and it'll help you tell you what kind of matchup it is, and it kind of gives you some examples of there as well, so that you can see if you're on the right track when you're putting things together. Because remember, some get Roman numerals, right? So the covalent bonds get, multivalent ones get those Roman numerals, the rest don't. And then there's polyatomic where you don't change the 4. So it just kind of helps with that flow. So print this off. It might be useful for you. It might be useful with one question. The next one, it might confuse you, whatever. You might not like it. It's totally up to you, but I just wanted to give that to you guys, okay? So that is available on the Moodle site under today's lesson, okay? So here is one of the 2 things that I want you to do. We are going to be playing Battleship, and I'm going to try this online. I do this in my classroom, so I'm going to try this online to see if we're able to do this. But in order to do this, you have to have your section done ahead of time before we play. So this is due today, all right? So what you have to do is put the 2 things together. So what you have to do is find the name if I combine those 2 atoms together. Find the name if I combine those ones together and these ones together. So basically, you're going to be combining, for example, H and S, that's an H, SO4, and you're going to be taking those 2, combining them together and figuring out the formula. That's not the formula. This is just me showing you what you're doing. And you're going to take those 2, figure out the charges, crisscross applesauce, all that kind of stuff, and write down what the formula is. It is due today because I need to mark it to make sure you're doing okay, so that when we actually play Battleship, you understand you got these right, and someone's like, hey, where is sodium bicarbonate? And you're like, I don't have it, it's a miss. And you're like, no, you actually do have it, it's right there, right? So I need to make sure that you guys have an understanding of this. You have to do them all. You have to fill this is like Battleship, right? The Battleship's entire grid, right? So you guys need to fill this whole thing in with the grid. This is going to be not as hard. I find it harder going from the name to the formula, right? This one's not bad because the charges are already there. All you do is have to crisscross applesauce. And then reduce if there's reducing. But other than that, that's really all it is. So that shouldn't take you too long. This is, I find, going from taking the 2 and putting them together is a little bit easier. And especially when I've given you the charges. You have everything that you need. You just have to crisscross applesauce, okay? So you have to get that done today. Okay, that is a must because I need to mark that so that when we actually do this, then I'm able to have you guys play and have some success with the play. Okay, all right, that is also found on the Moodle site, and there's a hand-in for it. What I would suggest doing, guys, you're going to have to be able to print. Okay, printing is super important with this program. You guys need to be able to print. What you need to do then is you're going to probably have to draw this out and write it in. That's going to be my best solution for that. Okay, so just redraw that out and do that. Okay, All right, so Monday, you guys are coming here from 10 to 11. Bring a pencil. We're just going to do some fun labby stuff and just get a little bit of getting you to kind of find some enjoyment in doing some science that has to do with chemicals and all that sort of thing. One of the experiments I've never done, it's not super hard or anything, but I can't get the supplies. I'm not telling you what it is, but I can't get the supplies until the morning of this. So I'm hoping it all works. It's going to be good. So yeah. All right. Good. Are Caitlin and I able to print it and do it against each other? We're going to be doing it during class, and I'm going to try to just get everyone to do it with other people. So you'll be doing it with someone else in the class. Yeah. But later on, you guys can play against each other if you want. Yeah, that's totally fine. Okay. And then the week of the 26th. So I don't see you guys the rest of this week. I'll see you guys on Thursday because we're doing the Experience OC, but no classes officially. Monday, I see you guys, and then I see you for class. But then the week of the 26th, which is that last week, I am trying to get us to go to KSS. I do not know the information yet. Magical Merle asked me about specifics. I still don't know. It's kind of out of my hands right now. So I'm going to try to see if I can peg something down. If it doesn't work that week, it might be March. I don't know. This is the week I'm trying for. If it doesn't work, it might be the following week. But I'm just giving you guys a heads up as much as possible. And we'll be doing a lab at KSS where we actually get to be in a lab, which is going to be kind of cool. Good. So do we fit? No, you guys only have to fill in this part. Only player 2. You're only filling in player 2. Sorry, wasn't very specific about that. Thank you for asking that. Only do the player 2 part. Okay? Thank you for asking that. Yeah, just do the player 2. You don't have to do the other because player 1 is going to be the player you're playing against. And I'm going to explain you guys how to play it. So don't worry about playing it. All I want you to do is just do this grid for player 2. That's all you have to hand in to me is this part of the grid answered. Okay? So if you are not able to make either one of these, we are hoping to have it all televised as well, just like normal for you. So you guys will be able to watch it from afar, but it'd be great if you guys came in to do some of these fun things that we get to do. Okay, so don't forget, Wednesday we have social studies. You guys have it. And Thursday is Experience OC. Look at my cute little man. He's so cute. Okay. All right. And yeah. What time is the quiz? So I'm getting to that. Katie, I'm just going to fill the battleship. You're creating compounds. So you're joining them together. So you're going to join this one together with this one and put the answer here. You're going to join this one with this one and put the answer here. You're basically, the work is done for you. So if I would have written hydrogen hydroxide, then you would have went, okay, H is a plus, OH is a negative. So basically you're starting at this stage of things. And now what you're going to do is do the crisscross applesauce. And I'm just kind of sort of making this up, and you would have a 1 here and a 1 here, but we don't put 1s there, so whatever. So basically, you're starting at this stage, and you got 2 things that you need to put together. Okay, is that good? Okay. It is like a times table, yes. I can't, good, okay. Awesome, okay, so, no one is trying to poison you. You can relax and eat your PB and jelly sandwich. PB, poison, lead. Lead is poison. Okay, so yes, quiz. You need to do it right away. It's like the other one where you have to print off or write the answers down, picture, scan it, upload it, and give it back to me in Moodle. You have to do that today. You have to do that today, and you have to do your battleship today. Okay? Your choice. I suggest printing off the flow chart. That'd be a good idea. You have some practice sheets. Do as many or as little as you want. You have the answer keys. So it's up to you how you do that. And then you have one worksheet that's due, and that's going to be due for Monday. I believe I have it in due for Monday. Okay. So 2 things you must do today. You have also work that was due today from last day. So, and you had the whole long weekend, and it was on Thursday, so you had the Thursday, you had Friday, you had Saturday, Sunday, and Monday, okay, so you guys had 5 days to get some of that stuff done. So if you're late on that, get that in. You have to do those 2 things, and then that 1 homework sheet is not going to be due till Monday. PE, make sure you guys get your PE done too. You guys, you have some logs that you have to be doing. So what I've done is I've done some revamping of it, and the PE logs have dates on them, so you guys can see where you should be handing those in. Again, don't hand it in Word. Make sure it's in PDF. Okay. I don't remember, Katie. Sorry. Good. Good. Okay. So that's it. Yeah. So if you have any questions, feel free to shoot me a message if you have any of that, but make sure you're doing those 2 things. You have to do the quiz. I would probably do the quiz now, get that out of the way, and then do the work of the battleship and upload that by today. Okay? And then you guys have some other stuff to do. I already answered that, Sean. I said I didn't know. Okay. Okay, perfect. So Luna, if you want to stay, I'm just going to read yours in a sec. But everyone else, have a good one, and I'll see you on Thursday at OC and for Experience OC. It's going to be really fun. So hope you guys can make that, and like to see you all there. Bye. Okay, Luna, let's look at your question. Luna, can you not catch the bus maybe or something like that? A lot of students take the buses. It drops right in front of us. You can't take the bus. There's no bus service. Okay. You'll just have to watch it on. You're just going to be missing out, unfortunately. Yeah, that's all I can say about that. Yeah, okay. All right, see you, Luna.